Welcome to podcast number 7 that deals with percent yield. Our goal in this podcast is learning target number 11. You need to be able to determine the percent yield for a reaction. Percent yield is a fairly simple concept because you are already familiar with the mathematics involved in percent yield. And we thought it would be a good idea to introduce percent yield by using a non-chemistry example to start. You will all take tests, you will all calculate your grades, and you're all familiar with how you do a percent for your grade. Well, what you do for your grade is very similar to what we do when we do percent yield in chemistry. Let's take a look at an example. If you take a test and get 75 points out of 80, you could easily figure out your grade. I think all of you would be able to take 75, divide it by 80, multiply by 100, and that would give you 94%. In fact, you could say there was a 94% yield on your test. Well, in chemistry, we do something very similar. The 80 points in the test, the highest number of points possible, is very similar to a term that we refer to in chemistry as the theoretical yield. 80 points is theoretically the highest number of points you could get. The 75 points that you earned on the test is your actual yield, and the actual yield is what you actually get in an experiment. So let's formally define those two important terms. Theoretical yield. Theoretical yield is the maximum amount of a product that can be formed when the limiting reagent is completely used up. The theoretical yield is a calculated value, and you will calculate that value using the same kinds of steps you've used in previous podcasts in this unit. The actual yield is the amount of product that's actually obtained in an experiment. This value, because it's obtained in an experiment, is determined in the lab. In a chemistry problem, this information has to be provided to you in the question. So the formula for calculating percent yield is this. You take the actual yield, you put it over the theoretical yield, you multiply by 100, and that will give you your percent yield. Let's take a look at a typical question. If you expect to get 34.5 grams of a product, if this is how much you expect to get, this is your theoretical yield. But you only get 28.4 grams. This value is your actual yield. And by the way, your actual yield is always less than the maximum that you expect to get. So if we take these values and we place them into our formula, we take the actual yield, 28.4 grams, divided by the theoretical yield, 34.5 grams, multiply by 100, and you get 82.3%. That's an 82.3% yield. We obtained 82.3% of the maximum amount that we could expect. Notice how I used significant figures in my answer, even with percent. Since we're dividing and multiplying in this problem, 28.4 has 3 sig figs, 34.5 has 3 sig figs. This number has an infinite number of sig figs. So we have to round our answer off so that it has as many sig figs as the term with the fewest. Well, each of these has 3 and this has an infinite. So 3 is certainly less than infinite. So my answer is 82.3%. Now, in the last problem, we gave you the theoretical yield and the actual yield. But sometimes, in some problems, you actually have to do a lot of work to figure out the theoretical yield. Those kinds of problems usually involve your finding out the limiting reactant in order to figure out the maximum amount of product you could obtain. Let's take a look at one of those kinds of problems. When 56.0 grams of N2 reacted with 56.0 grams of Li, 81.2 grams of Li3 formed. What is the percent yield? Well, this problem is telling us that 81.2 grams of Li3 formed. This is the actual yield. You actually got 81.2 grams of Li3N when this experiment was done. In order to find the percent yield, however, what we're going to have to do is to find out the theoretical yield. And in this particular problem, we're going to have to make use of what we've already learned about limiting reactant in order to find this out. So what we're going to do is we're going to work this problem out starting with 56.0 grams of nitrogen and figure out how much product, and then figure it out with 56.0 grams of lithium and find out how much product we get, and use that to determine the maximum amount of product we could get. So let's do that. So we have 56.2 grams of N2. This is going to be a long problem. I'll use my dimensional analysis. I'll put grams of N2 here. I'll put moles of N2 here. And 1 mole of N2 is 28.02. I got that from the periodic table. Nitrogen is 14.01, but because we're talking about N2, we have to double that value. And my grams of N2 cancel. I'm going to continue with my dimensional analysis, and I'm going to put moles of N2 here because I want these terms to cancel. And I can go from moles of N2 to moles of Li3N using my balanced equation. This 2 tells me that this value would be 2. This 1 here that's understood would tell me that this value is 1. If I stopped there, I would find the moles of Li3N, but that's not what I'm interested in. I'm interested in grams of Li3N, so I have to keep going. In the denominator here, I'm going to put moles of Li3N, and here I'm going to put grams of Li3N, and 1 mole of Li3N has a molar mass of 34.83 grams, which I get from the periodic table. I added up 3 Li masses and 1 N mass to get that value. These units cancel out, and I'm left with grams of Lin, and I find that the answer to this is 139 grams of Li3N. Well, I have to repeat that same kind of thing with grams of Li, so I'm going to start with 56.0 grams of Li. Again, it's going to be a long problem. I'm going to put grams of Li here and moles of Li here. 1 mole of Li has a mass of 6.941 that I get from the periodic table. Grams of Li cancels with grams of Li. I'm going to put moles of Li here. I want to find moles of Li3N. From my balanced equation, I know that this value is 2 and this value is 6 from here. My moles of Li cancel. I'm going to put moles of Li3N here and grams of Li3N here. And 1 mole of Li3N is, again, 34.83 grams. This unit cancels with this unit, leaving me with grams of Li3N as my unit, which is what I want. And this gives me 93.7 grams of Li3N. This then is the theoretical yield. As you saw in the previous podcast on limiting reactant, when you do this calculation, the smaller value gives you the amount of product that you get. Well, now we can finally work out our problem if we take 81.2 and we divide it by 93.7 and multiply by 100, we will get 86.7%. And so our percent yield in this problem is 86.7%. This is how you do percent yield problems. You should practice this in your packet.